In this section, we're going to talk about angles and their measure. Now, in the last section, we talked about angles in the context of triangles. But anytime two rays share a common endpoint, they form an angle. And their intersection point is called the vertex. Now, we say that an angle is in standard position when the vertex is at the origin of a coordinate plane and its initial side lies along the positive x-axis. All right, so we're looking here at an angle in standard position. Okay, so we have our vertex at the origin. The initial side is on the x-axis, the positive x-axis, and then we have the terminal side over here. Now, when the terminal side lies in a quadrant, right? You remember the numbering system for a coordinate plane. We have two axes, and they divide the coordinate plane into four quadrants. Quadrant 1 is where x and y are positive. Quadrant 2 is where x is negative and y is positive. Quadrant 3, both x and y are negative, and then in quadrant 4, x is positive and y is negative. Okay, so when the terminal side of the angle lies in a quadrant, we say that the angle lies in that quadrant. All right. Now, if the terminal side of the angle lies along one of the axes, we say that the angle is a quadrant angle. All right. So now you should be familiar with degree measure of an angle, right? We have one full rotation is 360 degrees. So 1 degree is 1/360th of a revolution. A right angle is 90 degrees. A straight angle is 180 degrees because both of the rays form a line. Okay, a straight line. Now, for angles in standard position, there are some conventions for measuring them. And so let's talk about that. So the first convention for measuring angles in standard position is that positive angles are measured in the counterclockwise direction. Okay, so we see over here next to where I just wrote that statement, we have an angle here that is a positive 90 degrees. Okay, so the initial side of the angle is along the positive x-axis. The terminal side of the angle lies along the positive y-axis. Okay, so that's considered a positive 90-degree angle. The next convention is that negative angles are measured in the clockwise direction. So we see over here an angle that measures a negative 90 degrees. All right, so we have an arrow that's going in the, or we have that's measured in the clockwise direction, and the initial side lies again along the positive x-axis, but now the terminal side lies along the negative y-axis, the negative part of the y-axis. All right, and the third convention for measuring angles is that large angles wrap around the origin more than once. So we can get angles that are bigger than 360 degrees. In fact, angles can go as big as we want. We could have angles of 1,000 degrees or a negative 1,000 degrees. We can go as high or as low as we want because we can just keep going, wrapping around the origin more than once. So you see in this figure over here, it looks like the angle wraps around the origin twice, right? So we went around the circle twice. 360 plus another 360 gives us 720. So you can see 360 plus 360, 720. All right. So let's take a look at the first example here on the next page. This example just says what angle in degrees corresponds to the given number of rotations. Okay, so if we just remember that there are 360 degrees in one full rotation, then if we have an angle that goes 1/8 of the way, 1/8 of a rotation, we're just going to take 1/8 times 360 degrees, and then we're going to get 45 degrees. Right, when you take 1/8 of 360. Because 1/4 of it would be 90, and then half of a fourth is an eighth, so 45 degrees. So, or you could multiply the fractions, right? So now 5/6 of a rotation, 5/6, again, we're just going to multiply 5/6 times 360 degrees. Now, with this, I probably would just, we can divide this by 6, right? 36 is divisible by 6, so it's 6 times 6. So if we divide 360 by 6, we're going to get 60, right? And so then this, if you take the 5 times 60, we're going to get 300 degrees. Okay? All right, so now we have a negative fraction of a rotation. So minus 1/12 of a rotation. So now we're measuring the angle in the negative direction, the clockwise direction. And so we're just going to take a negative 1/12 times 360 degrees. And then now 36 is divisible by 12. So that's 3 times 12. So if I divide 360 by 12, I'm going to get 20. So you can see, no, 360 divided by 12 is 30. 30, hang on, 30. I was going to say that didn't seem right. 30. So this is just a negative 30 degrees. Okay, 1/12 of the way around the in the negative direction. So 1/12 of one full rotation. All right, now we have 7/4. Okay, that's an improper fraction. That's bigger than, it's a number that's bigger than 1. The numerator is greater than the denominator, but we can still do this. We have 7/4 of 7/4 of a rotation, right? So what is that? That's like 1 3/4 of the way around the circle, right? Or sorry, around 1 3/4 rotations. Okay. So, but I can just take 7/4 times 360. I'm going to divide this. I'm going to get what, 90, right? When I divide 360 by 4, and then I can take 7 times 90, and I'm going to get 630 degrees. Okay, so 7/4, like I said, that's a full 360 plus another 3/4 of the way around the circle. So there we go. We might as well do, well, let's see. I might as well do the next example as well. So now in example 2, it says to draw each angle given in degrees in standard position. Okay, so we're going to draw a coordinate axis here. All right, so I'm just going to draw a coordinate plane here, and I'm going to draw this in standard position. All right, so why don't I use red or something like that for the angles, because so the, oh, gee mini, oh, sorry. All right, so I'm just going to draw the initial side of the angle on the positive x-axis, right? And then I'm looking for an angle that's 60 degrees, okay? So now I know this is 0 degrees, right? A quarter of the way around, this is going to be 90 degrees, right? That's a right angle. And this is 180 degrees, okay? Now down here, this is going to be, what, 270 degrees? Now, so I want 60. So I know that this angle lies in the first quadrant. And so you remember drawing the 30, 60, 90 triangle. So 60 degrees is probably something like that. Okay. It's about 2/3 of the way. All right. So this angle right here would be 60 degrees. Okay. Now, a lot of times we don't draw the initial side. We only draw the terminal side. So I think I'll do that for the next one here. So again, I'm going to draw my coordinate plane. Okay, so I have an x-axis and a y-axis. Try to draw them at right angles to each other reasonably. So again, I'm just going to draw the terminal side here, because I know that if the angle's in standard position, the initial side lies along the positive x-axis. Now a negative 45 degrees, now 45 is half of 90, we're going to measure in the negative direction. So we've got halfway to, this would be, this down here would be a negative 90 degrees, right? And so this angle right here, measured from the positive x-axis, would be a negative 45. So negative 45 degrees. Okay, so here's my terminal side down here. All right, now I didn't draw the initial side, like I said, because a lot of times we don't draw the initial side. We just, it's a given that it's going to be along the positive x-axis. All right, let's figure out where 210 degrees would be. So again, I'm going to draw my axes. I'm going to have my initial side along the positive x-axis. This is 90. This is 180. Now this is 270, so that's too far, right? So I'll put a degree on here. And so it's somewhere between 180 and 270. Now I know that if I take 180 and add 30 degrees, I get 210. So I'm going to draw my angle here at about 30 degrees with a negative x-axis. Okay, so roughly 30 degrees with a negative x-axis, right? Because it's 210 is 180 plus 30. So I went to 180 plus 230 more. So my angle is measured all the way from the positive x-axis, right? I'll get rid of that. So that is a 210. All right, 210 degree angle. Okay, measured from the positive x-axis now, and this was 0 degrees. All right, one more, 450 degrees. Okay, well, that's bigger than 360. So if we subtract 360, looks like we'd have 90 left. So this is essentially 360 plus 90 degrees, right? 360 plus 90 is 450. So what I'm going to do, I'm going to draw my axes again. And I'm going to measure from the positive x-axis. And I'm going to go once around the circle, right? Plus another 90 degrees, right? So actually I should do that in red like I did before. But yeah, well, that's okay. Let's do it in red so it matches with the other ones. All right, so we'll do that again. We're going to go once around the circle plus another 90 degrees, okay? Oops. All right, I didn't want it to turn into a circle. All right, so that's 90 degrees. So the terminal side of my angle would lie along the y-axis like that, all right? So that is 450 degrees. Okay. Now notice we're going to talk about coterminal angles, but the terminal side is at the same spot as the terminal side of a 90 degree angle. So sometimes we call those we call those coterminal angles. So essentially 450 degrees is coterminal with 90 degrees. So we'll talk more about that later. But that's enough for now, and I'll see you in the next video.